Hello everyone, and welcome to another session on the Petroleum System. In our previous sessions, we talked about the source rock, which is considered the most important element of the petroleum system because it is the place where hydrocarbons are generated. We also discussed hydrocarbon generation, including the transformation of organic matter into oil and gas under suitable temperature and pressure conditions. In today's session, we will complete our journey through the petroleum system by discussing hydrocarbon migration, hydrocarbon accumulation, and traps. These are the final stages that determine whether hydrocarbons can be discovered and produced economically. So, let's start with hydrocarbon migration. Hydrocarbon migration is the natural movement of oil and gas from the source rock to other rock formations. This movement takes place over geological time after hydrocarbons are generated and expelled from the source rock. Once expelled, they migrate through permeable pathways until they either escape to the surface or become trapped inside a suitable reservoir. Hydrocarbon migration is driven by several geological forces. These include continued burial of sediments, sediment compaction, the increase in fluid volume during hydrocarbon generation, and the buoyancy force resulting from the density difference between hydrocarbons and formation water. Since hydrocarbons are lighter than formation water, they naturally tend to migrate upward whenever a permeable pathway is available. Now, let's describe the different types of migration. Actually, we have two main types of hydrocarbon migration: primary migration and secondary migration. The primary migration is the movement of hydrocarbons out of the source rock. This stage is considered one of the most difficult processes because hydrocarbons must escape from very low permeability rocks, such as shale. The secondary migration starts after hydrocarbons leave the source rock. During this stage, oil and gas move through permeable carrier beds, such as sandstone or fractured carbonate rocks, until they reach a suitable reservoir where they can accumulate and eventually become trapped. Now, after discussing hydrocarbon migration, let's move to the last stage of the petroleum system, which is hydrocarbon accumulation. At this stage, hydrocarbons finally reach the reservoir rock. However, not every rock can act as a good reservoir. A reservoir rock must satisfy two essential conditions. The first condition is porosity. Porosity represents the pore spaces inside the rock where hydrocarbons can be stored. Reservoir rocks may have low, moderate, or high porosity, depending on their depositional environment and diagenetic history. The second condition is permeability. Permeability measures the ability of fluids to flow through interconnected pore spaces. Even if a rock has high porosity, it cannot become a productive reservoir unless those pores are connected, allowing hydrocarbons to move freely. Once hydrocarbons enter the reservoir, they continue migrating until they encounter an impermeable sealing rock, such as shale or another dense rock layer. This impermeable seal prevents further migration and creates what we call a hydrocarbon trap. Inside the trap, the fluids become naturally stratified according to their densities. Gas, being the lightest phase, occupies the upper part of the reservoir. Oil is located beneath the gas, while formation water, which has the highest density, occupies the lowest part of the reservoir. Reservoir rocks can generally be divided into clastic reservoirs and carbonate reservoirs. Clastic reservoirs, such as sandstone, are mainly composed of silica grains and usually exhibit intergranular porosity. Carbonate reservoirs, on the other hand, are mainly composed of limestone or dolomite and may contain fossil or coral fragments. Their porosity is often more complex because it can be controlled by fractures, dissolution, or vugs in addition to the original depositional pores. Now, let's look at the different types of hydrocarbon traps. The first type is the anticline trap, which is a structural trap formed by tectonic deformation. As hydrocarbons migrate upward, they accumulate at the crest of the folded structure beneath the sealing rock. The second type is the stratigraphic trap. In this case, trapping occurs because of changes in rock type, pinch-outs, or depositional variations. As you can see in the figure, hydrocarbons are trapped where the permeable reservoir rock is sealed by impermeable rocks. Finally, we have the fault trap. Here, fault movement places a permeable reservoir rock against an impermeable sealing rock, preventing further hydrocarbon migration and allowing hydrocarbons to accumulate. With that, we have completed our discussion of the petroleum system, starting from the source rock, followed by hydrocarbon generation, migration, accumulation, and finally trapping. I hope this series has given you a clear understanding of how a petroleum system works and how all its elements are connected to form a successful hydrocarbon accumulation. Thank you for watching. If you enjoyed this series, don't forget to like, share, and subscribe. See you in the next session.